In this video, I'm going to show you the chain rule, which allows us to compute rates of change of um, dependent variables with respect to independent variables other than the one that's used in the function that defines that dependent variable. So to illustrate what I meant in that word salad there, here I have a function p of x that gives me the profit from producing x units. So we have this function formula that gives us p of x. But what I really want is the rate of change of profit with respect to time. So here I have this other function to help me out with that. This relates the number of units produced to the time in days that it took to produce them. So given this relationship, profit in terms of units, and then this function, units in terms of days, I can compute the rate of change of profit with respect to time, where time is measured in days. So instead of trying to come up with a function by combining these two, instead of coming up with a function that determines profit from days directly, I can work with these derivatives of these functions individually and combine them in order to get that rate of change that I'm after. So even though I don't have a function that relates profit to time, I can still compute the rate of change of profit with respect to time. So that's what I meant by respect to an independent variable t, other than the variable x that was used to define my profit function. So first, I need the rates of change of these functions with respect to their respective independent variables. So I have here the rate of growth of profit with respect to units. So that would be p prime of x. But I'm going to use another notation for a derivative that will be helpful in understanding the chain rule, and that is dp dx. So this is another very common notation that's used for the derivative. I haven't used it yet in the videos, but it's helpful now. So derivative of p with respect to x. It's not literally a fraction. Informally, you could think of it as one because the derivative is defined in terms of a slope that is the change in p divided by the change in x. And also remember that the meaning of a derivative is the slope, the actual slope, change in p over change in x, of a tangent line. So using our differentiation rules, we can take the derivative of this function and we get minus 2x plus 200. Now, next we compute the growth rate of the production with respect to time. So the derivative of this function. So that would be dx dt. So we take this derivative in the usual way. So 2 times 1.5t, so that's 3t, minus 3. Now, we can combine these two derivatives to get a growth rate of profit with respect to time. So that would be dp dt, and to get this derivative from these two, we just multiply them together. So we have dp dx times dx dt. And informally, you could think of this as the dx is canceling, and that's why the product of these two derivatives gives us dp dt. Again, these are not literally fractions, but it's helpful to think of it that way to remember how to use the chain rule. That in a sense, you are canceling the dx's. So when I combine these derivatives, I have minus 2x plus 200 times 3t minus 3. But ultimately, my answer should be in terms of t. So wherever I see x, I should replace it with its definition in terms of t. So that would give me minus 2 times, and I'll substitute this in here, 1.5t squared minus 3t, and then don't forget the plus 200, and then times 3t minus 3. So now, if I want to know the rate of change of profit at a particular time, I would just have to substitute that value of t into this expression. So, for instance, if I want the growth rate of profit at t equals 3 days. So that would be dp dt at t equals 3. Sorry, the recording cut out right there. So here's where I left off. dp dt, and the vertical bar means I'm evaluating. I'm evaluating this derivative at t equals 3. So now I can use this formula down here with t equals 3 substituted. So that would be minus 2, 1.5 times 3 squared, which is 9, minus 3t, so that's minus 9, plus 200, times 3t minus 3, so that's 3 times 3 minus 3. So if I try to simplify this, I get, so minus 2, 1.5 times 9 minus 1 times 9, that's a half times 9. But that's multiplied by minus 2, so I get minus 9 plus 200. And then 3 times 3 is 9, minus 3 is 6. So that would be 191 times 6. Now, yes, normally you would run to your calculator at this point, but that would be the same as, actually, it's easier to figure out if I forget this and work it out this way. So that would be minus 9 times 6, that's minus 54, plus 200 times 6, that's 1,200. So that would be $1,146 dollars, assuming profit is measured in dollars per day, because T is using units of days. So that would be the rate of change of profit measured at the end of t equals 3 days. Again, the derivative is an instantaneous rate of change. So I can figure out the rate of change of my profit at any time by plugging in the appropriate value of t. So chain rule comes from multiplying derivatives together. So dp dx times dx dt informally cancels the dx's to give us dp dt. So you compute the derivatives of the individual functions, multiply them together, but make sure that your units, your ultimate independent variable t, that everything in your answer is in terms of t. So whatever inner function you have, make sure to substitute that in here to make sure that your answer is in terms of the correct variable.